Okay, so today's video is going to be about time dilation, but I have made a video in that it was same, but today we will the method to derive the equation of time dilation equation. The method used will be different. Will be different. In that, the main concept to derive that was we needed to know about trigonometry. This one we don't need. We will not be using sine, cos, or tan. So what I mean. Okay, we will not be doing that. We don't need this. Okay, imagine there's a person. There's a person standing here. Okay, and he is looking at two mirrors. One. This is mirror 1. This is mirror 2. Okay, so this person is S. He's S. His name is S. He's at a non-moving frame of reference. What he will see is that this photon, this is what we call atomic clock, light clock. This photon, what will it happen to this photon? It will move up and then it will move down, right? So what we will see, the length it covers is 2L, and this 2L over C is the same as saying d over V. Here I will not take V, I will say C as well, because speed of light is constant. Is the same as saying time. This is how we calculate time. Okay, formula of time I just made it to calculate time for a light clock. Okay, so now let's have a different scenario. Someone who is moving. This is for improper time, improper frame of reference. M1. Yeah. M1. Oh, sorry. M1. M2. M2. Wait, sorry. M2. Okay. Since he is moving, these two will have different position. As we know that when we observe or we are observing something with respect to its movement or the person who is moving, we will see the event. Remember, event has different meanings. Okay, so event will be in different happening at different places. So this will be the speed. Okay, this will be the speed of the photon. Now the direction, the distance. This, then again back. This now we can observe by this over here. Wait, let me change color. This one. We can observe that the combination of these two is more than this. Okay, remember that. Okay, now so now let me emphasize or let me increase the data we are given. This is V for this box moving or this mirror moving, and then again same here goes over here, and so on. We as unlimited to how parallel we are going, how far we are going. Same goes for this one. Actually, this is just one part of that experiment. If we like move on over here, it will be this, and move on here, it will be this, and so on. But I don't want to increase the information. We will just look at one part of it because we only, the information we need will be fulfilled by this area. Okay, so now L oh again, I think last time we also had Pythagoras theorem. Whenever we have like situations like this, always it's better to convert it into Pythagoras theorem to make it as simple as possible. Pythagoras theorem. It's Pythagoras or Pythagoras? Pythagoras theorem. My favorite. It's the easiest of them all because it makes everything simple. Then now since this okay over here, this is time delta t. When I put this, it means improper, but it's a proper time. And over here now we will be talking about delta t with this. This means improper, improper time. Okay, improper time and proper. Sorry, let me remove proper time. Okay. Now let me make the equation from here for delta t improper. We only need this part. We will be focusing on this part because Pythagoras theorem is what? It focuses on what do you call that? It focuses on right angle triangle. Okay, so we have again 2 okay, so L square, because we know that this is B square, this is C square, this is A square. L square plus V delta t square over 2. Okay, we're talking about half of this. We're not talking about this. We're not talking about this full, but we're talking about only half this part. This part only. Okay. Now let's add. Right now, this is we're here. We're not emphasizing the speed of light. Let's add speed of light into this equation. When we add speed of light into this, we get 2 over c, and then again L square plus V t square over 2. Now this is talking about this photon. And then let's move on to next page. Okay, yeah. Then let's expand more. This can be expanded to c t over 2 square. I'll tell you why I put square. And then 2 over c square root of L square plus V delta t square over 2. So when I remove the square root, what I get? C delta t over 2. I expanded this square equal 2 over c. What do we get? L square plus v delta t square, square. Remove this. And then it can be further simplified into, this is one way of defining it. Second way of defining the equation is, it's one way. Number one way to define it. Number two way to define it is c square minus v square t square over 2 L square. Number two of way to describe the same equation. T delta equal 2L over C over 1 minus V square over C square. And the one and only, then we have our famous T delta equal T over 1 minus square root V square V over C square, and then this transforms into our final answer Vt gamma. And gamma is what? Gamma is this. So these are multiple ways. Okay, let's talk about what is difference in all of these. Here we're L. Here this is on L, length. This equation is for length. This equation is for, wait, am I wrong somewhere? Wait, sorry. This is not here. This is only, yes, over here. Yeah. This is for C delta T improper over 2. Okay, the same thing. It's for improper time of rearranged equation. Yeah. So this is for time. This is for length. And this is for yeah. So it's a simplified version. This one is the simplified version of this one. Let's move the arrows. Wait, let me write this. Simplified version. Okay. What else can we add here? Remember, V is for the object. V, wait, let me write it somewhere over here. V, the speed of moving object. And one more thing, whenever we are talking about time dilation, we will always have two velocities. Always, let me write over here. Always have two velocities. Okay. What I mean by two velocities? One, speed of light. Second, speed the object observing that event that object who is observing. Here I said speed of light. Yeah, everywhere we will have speed of light because speed of light is the common factor in this. Let me think, what else additional information can we have here? Improper. So here we didn't use any sine, cos, theta. This is, okay, let me write over here. second method. But I think even this method is not hard, but I prefer the first method, and that method should be used in if the user or if the deriver knows the trigonometry. But if he knows trigonometry, that concept will be piece of cake. Okay. But even this will work. It's the same thing. Here, the difference is that we have many equations derived, but all of them have the same concept. Thank you.